ladies and gentlemen.
So let's talk circles. So first and foremost, I'm going to apologize. This is going to be a long one because there's a lot to talk about when it comes to circles. So we define a circle as a set of all points that are equidistant from a fixed point, which we'll call the center point. The distance from the center to the edge is called the radius. And if we connect two points on the outside edge of a circle and connect them via a line segment, that's called a chord with an H. If that chord goes through the center, it's called the diameter, and that is twice the radius. Quite a few definitions right off the bat. Let's keep going. So the circumference of a circle, or its perimeter, is 2 times pi times r, or pi times the diameter. That's actually how pi is defined. Pi is defined as the ratio of the circumference of any circle to its diameter. So, interesting tidbit there. And pi is irrational because that ratio is irrational. Fun stuff. Let's try a problem. Circle A has a radius of 4 millimeters. What is the circumference of circle A? Well, it's got a radius, then we can do C is equal to 2 pi times 4 in this case, which would just be 8 pi, and our unit would be in millimeters. It's a one-dimensional thing, circumference or perimeter, so that's all we need. No square or anything like that. So 8 pi millimeters, not too bad, right? What about area? Area, the amount of unit squares we can fit in something for a circle, is a little strange. We have area is equal to pi times the radius squared. We actually have the exact same numbers here. We have a pi, we have an r, and we have a 2. They're just in slightly different places. So because area is a two-dimensional object or two-dimensional thing, we can square it, and our units will be squared, so it makes sense the radius would be squared in this case. So if we have a circle and its diameter is 12 meters, what is the area of the circle? Well, diameter is twice the radius, so the radius of this would actually be 6 meters. And now we can use our formula. The area of a circle is pi times the radius squared, so 6 squared. 6 squared is 36, so we have 36 pi, and then we'll have meters squared as our unit, and that is our area. So not too bad, just kind of the area and perimeter stuff that we had done before, but specifically with circles. Let's do even more vocab. The central angle is formed when we have two radiuses of the same circle, meet. So in this case here, the central angle would be 90 degrees because we have a radius and another radius meeting at 90 degrees. So that center in the middle is the central angle. And you should be familiar with this. The angle associated with a circle is 360 degrees. So if we form an angle via the middle of the circle, via the center, that angle should be between 0 and 360 degrees. Now, more definitions. A section of the circle is called an arc. So this is called an arc. From A to B is called an arc. We have two quantities associated with an arc. We actually have a degree measurement. So how many degrees was that arc using in terms of the central angle? And that is called arc measure. So in this case, this is an arc measure of 90 degrees. So the measure of arc AB, that kind of has like a swoosh over it, is 90 degrees. And the angle, the central angle, is also 90 degrees. So these two things should always be equivalent to each other. Now this is called a minor arc because it is less than 180 degrees. Where if we go the other way around, if we go through D, that is called the major arc because it's going to be more than 180 degrees. And the major difference between them in terms of notation is typically you'll see 3 letters when it comes to the major arc because it tells you specifically we're starting at A, going through D, and ending at B. And these two, the major and minor arcs, should always sum to 360 degrees. Makes sense. That's 360 degrees around a circle. There we go. Arc length is the portion of the circumference. How much of the circumference do we actually have? The distance being traveled here. That is found by multiplying the circumference by the fraction of the circle that we have. So let's try one out. A circle with a diameter of 10 inches has a central angle of 45 degrees. What's the length of the arc? So let's figure this out. We have 45 degrees out of the entire 360 degrees. So that's the fraction of the circle that we have. Now the circumference of the whole thing would be either 2 times pi times r or pi times the diameter. So we can actually just do 10 times pi. Well, 45, 360, well, there's 4 90s in 360, which means there should be 8 45s. So this is actually just 1/8 times 10 times pi, which could turn into 10/8 pi or 5/4 pi, or if you want to be even more fancy, you could say it's 1.25 pi, and our unit is going to be inches for all of them. So we could say that this is inches or this is inches. And both of these would be acceptable answers. I kind of like the fractions myself, but you do you, right? Next up is inscribed angles. So a central angle is an angle formed at the center. The inscribed angle is an angle formed on the edge by chords. So we have a vertex on the edge, and we have chords being our rays off of the angle. And the inscribed angle is 1/2 of the arc associated with it, or it's 1/2 of its central angle, its corresponding central angle. So if this is 30 degrees, then this would be 60 degrees, and the arc itself would be 60 degrees. I know it's more than that, but just for the example, right? So if I go from the inscribed to the central, I double. Inscribed to the arc measure, I double. Going from arc measure to inscribed, I halve. Going from central angle to inscribed, I halve. And remember, going from measure to the arc to the central angle is the same. So that's kind of the relationship that we have, and that's what all of this lovely math is saying here. Let's put this into practice. So the most common way I see this is a problem that kind of looks like this. They kind of give you a diameter here, and then a chord, and this is the diagram they give. So if we have that the minor arc from G to H is 130, so G to H, this arc is 130 degrees, we need to find the measure of GHA. GHA is here, so let's put a little X there. Well, if I know that this part is 130 degrees, and this is a diameter, I know that the whole half of this circle should be 180, meaning that this is 50 degrees, because 180 minus 130 is 50. And if the arc measure is 50, its corresponding inscribed angle should be half, or 25 degrees. So if the arc is 130, the central angle is also 130. Now I have a triangle. I know about triangles. The interior angles of a triangle sum to 180. So 25 plus 130 plus whatever x is should be equal to 180. Well, 25 and 130 make 155. And what do I need to add to 155 to get to 180? Well, I know it's going to end in a 5. That would bring me to 60, and I need 20 more. So x is equal to 25 degrees. And there you have it. Not too bad. Just got to figure out where you're going, what you're doing. Let's do another one. So we're going to find the value of A, which is here. And I'm given that this arc measure is 105, this arc measure is 62, and this arc measure is 75. Well, if I have 3 of the 4 arcs of this circle, there's 360 degrees total to share. So that means that 105 plus 62 plus 75 plus this arc here, which should be double A, so we can call that 2A, should equal 360. And if we solve this, we can find out what A is. So let's add our numbers together. We have 5 and 5 make 10 plus 2 is 12. We have 7 and 6, which make 13, plus 1 is 14. And then we have those two together make 2. So we have 242 plus 2A is equal to 360 degrees. subtract the 242, and we need to borrow a little bit. So that leaves us with an 8, that leaves us with a 1, and that leaves us with a 1. So we have 118 to split in half. Half of 100 is 50. Half of 18 is 9. So that means that A is equal to 59 degrees. Not too bad. Another vocab word, tangent lines. So a tangent line is a line that touches the circle once, and only once. So this line here is only touching the circle at this point. And the tangent line is always going to be perpendicular to the radius, specifically at the point of tangency, where the tangent line intersects the circle. So at this particular point, we get a 90-degree angle, which is really nice because then we can use some of our right angle trigonometry or our Pythagorean theorem to help us with some questions. So let's try one out. So WX and WZ are tangent to the circle Y. Find WV. Well, I know that this angle here, this is radius and this is a tangent line, this should be 90 degrees. I also know that the only way for this line here to be tangent to the circle and this line here to be tangent to the circle and they intersect, which is really what we care about, these distances have to be exactly the same as well. So now we have a right triangle, we figure out what this missing side is. But we have even more information. The radius is 8. That means y to v is also 8. So if we call this x, we can set up a really nice equation where we can just solve for x using Pythagorean theorem. So 8 squared plus 15 squared is equal to x plus 8 squared. Well, 8 squared is 64. 15 squared is 225. And now I've got some weirdness here. Let's leave this as is for now. Let's keep that a little complicated looking. Let's add these together. 4 and 5 make 9, 6 and 2 make 8, and we have that 200. So we have 289 is equal to x plus 8 squared. We can undo the square with a square root. So we can take the square root of both sides, and we are left with x plus 8 on the right, and the square root of 289 is 17. So we have x plus 8 is 17. If we subtract 8 from both sides, we end up with x is equal to 9. Not too bad. Hopefully we're feeling good about this. There's a lot of stuff with circles. We did a lot in this lesson. So please, please, please take your time with it, try out some problems, and ask some questions. Good luck to you, and I look forward to seeing you in the next video.